All right, today we're going to be working on solving systems with substitution. This is kind of part 2 of working through substitution here. I have your assignment listed here for you. There's a couple that I just want you to note that for some of the problems, I'd like you to work like number 2 through 7 without Desmos. I want you to practice the skill of substitution. For questions 9 through 11, you're certainly welcome to use Desmos. I would. It's good to practice to use a graphing calculator. And 14 through 18, you have the choice. For each of these slides, what I want you to do is after you read the situation, I want you to hit pause for a minute and then think about if you know how to solve it without my guidance. And you can do it right onto your notes page and then hit play to see if you got the same thing as I did. If you're not sure how to do it, then you can just hit play right away and then you can watch me solve all of them. However, it's a good strategy if you hit pause, try it yourself, and then just confirm that you did it the correct way. So first I want to just recap what we talked about last class is solving using substitution. And so we're going to be using our 2 equations that we have here, making our system of equations. And we're going to replace our y in our first equation with this 2x minus 4. Since this is solved for y, we know that we can take this quantity of 2x minus 4 and simply substitute it in for the y that's in the other equation. So now we have 9x plus 3 times the quantity 2x minus 4 equals 27. We'll use the distributive property to help us solve. So we have 9x plus 6x plus negative 12 equals 27. This would make it 15x to combine like terms. And then we're going to go to adding 12 on both sides, which gives us 15x equals 39. Divide both sides by 15. And we end up with x equals 2.6. Then to solve for our y value, we're going to substitute in what we know for our x. So y equals 2 times 2.6 minus 4. And that ends up to be y is 1.2. So our solution set for this one is going to be 2.6 and our y value is 1.2. And I wrote super big so I don't have a lot of room on my screen, but to check that, we would need to replace this for our x value and this for our y value in both of our equations to ensure that we got the correct answer. So for this next system of equations, if you understand how to do this one, hit pause and try this one out on your notes page. I'm going to solve it with you, but I'd like you to try it first without me. So just to remind you of how to solve a system of equations, for this type for substitution, you want to isolate one of the variables. You want to get one of the variables all alone. Then you want to plug the value of that variable into the other equation and solve for that other variable. Once you have the value of one variable, you can use that to help you solve for the second variable. Go to our first equation, figure out one of these we're going to be solving for x or solving for y. So that's our step 1 is isolating a variable. So I'm going to take this guy right here and I'm going to take him and say I'm going to solve for x. So then I'm going to add y on both sides and I get x equals 5 plus y. So now I've solved for my x. Then I can use my x as my equation to help and substitute in for my other equation. So I'm going to take this one, and every time I see x, I'm now going to replace it with the quantity of 5 plus y equals 10. Then we get 40 plus 8y, got to distribute both of those in, plus 2y equals 10. 40 plus 10y equals 10. Then, solving, subtract 40 on both sides. We end up with 10y equals negative 30 So our y has to be negative 3. Then we're going to take that value and replace it into our equation to figure out what x would be. So we have x minus, and then our y is negative 3. So be really careful that that negative 3 still carries up there even though we have that minus, because that minus has to be there from my equation, and that negative 3 is what we have for our y. This equals 5. Well, this is the same thing as x plus 3 is 5, so we know x has to be 2. Then, to check our work, we always want to make sure we check. To check our work, we're going to go back to our other equation. So we solved it for this first one right here, so we're going to use it in the second equation there. So now I'm going to replace my x and my y values. So I'd say 8 times my x value is 2, plus 2 times my y value is negative 3. And we're going to see if that equals 10. If it does, it's a true statement. If it doesn't, well then we've got something else going on. So we have 16 plus negative 6 equals 10. And yep, that is true. So we'll have a little guy here with his little fancy hat because he's happy because we solved it right. So in this next problem, we're going to be interpreting this information from the story problem and coming up with a system of equations that represents the situation. So the owners of a carnival have found that twice as many children as adults come to a carnival. If 3,570 people attended the carnival, write and solve the system of equations. So we know that we have to define our variable. So I'm going to define my variable as C equals children and A equals adults. Always a good idea to make sure you define those variables so you know exactly what you're talking about. So one of the pieces we know is that children plus adults is all of our attendees, 3,570. Then we know that twice as many children as adults come to the carnival. So we know that children equals 2 times the number of adults. So now we're going to use substitution to determine how many children and how many adults came. Since we're already solved for one of our variables, we want to make sure that we use that one. It's the easiest way to go. So now we're going to replace this C up here with our 2A. So we'd have 2A plus A equals 3,570. Then that would be 3A equals 3,570. Divide both sides by 3 and we get A equals 1,250, and that, remember, stands for adults. So then we're going to use that to help us determine how many children. So we know children is 2 times A, so children would be 2 times 1,250, the number we came up with from our substitution. So children is 2,500. All right, last one here. So this one we're going to be looking at another system of equations, but we're going to have to figure it out from a story problem here. So a farmer bought 100 acres of land. Part of it is $37 per acre of forest, and the other part is $45 per acre of fields. Total cost $4,220. So first I want to figure out what my variables are going to stand for, and in this case I can't really use F for forest because it also could be for fields and that might get confusing. So I'm going to assign X and Y. So X I'm going to give to the forest, and Y I'm going to do for fields. So then from that we have to look at our two conditions we have. We know that there's a total of 100 acres of land, and that's made from a combination of forest and fields. So the two of them together add up to be 100. Then our other condition is that we know how much was spent, the total amount that was spent. So we know that $37 per acre of forest plus $45 per acre of fields equals the 4,220. So then we need to figure out which one is the easiest one to solve for a variable. I think this one up here is pretty easy. So for this one, I'm going to solve for x. So now I have x equals 100 minus y. I just simply subtracted y from both sides to end up with this new equation. So I'm going to go back down to here into my original equation for that one, and I'm going to replace that x with my new look at x. So we have 37 times 100 minus y plus 45y equals 4,220. Then we're going to distribute. So it's 3,700 plus negative 37y plus 45y equals 4,220. Then subtract 3,700. And then here, we're going to combine those like terms. We get 8y, and this is 520. Divide them both by 8, and we get y equals 65. So reminding ourselves of what that means it's 65 acres of fields. Then, to just figure out how many it is for the forest, we could plug it back into our original, and we'd say x plus 65 equals 100. So x then has to be 35. To check, we need to go back to our equation that we didn't use to solve our x value. And so we're going to plug in our values that we found out. So 37 times 35 plus 45 times 65, and that all should equal 4,220. And it does. So we got it right. All right, so today for your practice, head to your textbook. It's in section 10.3 on page 598. If you don't have your textbook with you, that's just fine. Just remember you have a link on Schoology to the online textbook, and then just hop to page 598. Remember, for questions number 2 through 7, I'd like you to use substitution, so no Desmos for that one. Questions 9 through 11, you have the choice. You can use it with Desmos or not. Might as well use Desmos. And then for 14 through 18, it doesn't really apply. All right, good luck.